Today's lesson, lesson 21, looks at measurement units and converting them between each other. So if you see on the front page of your packet, it says conversion tables contain ratios that can be used to convert units of length, weight, or capacity. Rip off the conversion table at the back of this sheet to help you solve the problems in this lesson. So what I have done is I have taken the portion of the conversion table that I'm going to want to help me answer the first few questions. So we are going to be using equal fractions, equal labeled fractions I should say, in order to do the problems that we're going to look at today. If we look at the beginning, it's asking us to identify the ratios that are associated with conversions between feet, inches, and yards. So I just found the part of the table that dealt with feet, inches, and yards. The first problem says 12 inches equals blank foot. So if we look, we can come to feet, and we can see that 1 foot equals 12 inches. So I would put 1 here. The ratio of inches to feet is going to be 12 inches to 1 foot. So I'm going to actually write that as 12 inches over 1 foot, just so I'm getting in that habit of using a fraction that is labeled, because we are going to want to use equal labeled fractions to solve these problems. So if 12 inches is 1 foot would then be 12 inches. The ratio of feet to inches is 1 foot to 12 inches. So again, remember with ratios, order does matter. When we use our equal fractions, it really won't matter which one we're putting on top and which one we're putting on the bottom in our numerator or denominator, as long as we're lining up our units. So the next one says 3 feet equals blank yard. And if we go over to our conversion table, we'll see yards written here. So if we look, we can see between yards and feet is right here. 3 feet is 1 yard. The ratio of feet to yards is 3 feet, 1 yard. Okay, and then the last one, 1 yard equals blank feet. Again, it's the same thing, just reverse order. So this would be 3 feet. And the ratio of yards to feet would be 1 yard over 3 feet. Okay, hopefully that you found this part fairly easy. It's just looking at a table, finding the equivalent unit, and then creating a ratio using a fraction. Okay, so looking at example 2, make a record of your work before using the calculator. It does say work with your partner. I'm just going to do this as an example for right now to find out how many feet are in 48 inches. Use the conversion rate of 12 inches per foot, or 1/12 foot per inch. And again, that's just going back to the table. I just brought that table over again. I'm looking to go between feet and inches, so again, I can use either of those two. So what I'm going to do is when I go to that table, or seeing that they gave me 12 inches per foot, I'm going to write a fraction with those two units. So I would do 1 foot over 12 inches. I'm going to set that up equal to another fraction where my numerator is feet and my denominator is inches. Again, I want to make sure my units line up. In the problem, they're telling me I'm trying to find for 48 inches, so next to inches I'll put 48. I would then need to figure out what I multiplied 12 by to get 48. To do that, I can do 48 divided by 12, which is 4. So 12 times 4 gave me 48 inches. 1 times 4 tells me that 48 inches is equal to my answer of 4 feet. For the next problem, it says how many grams are in 6 kilograms. So I'm looking to go between grams and kilograms. If this added information was not here, I would want to use the metric conversion table on my back page that goes between kilograms and grams. It's the same information that they tell us here. So the rate would be 1,000 grams per kilogram. The unit rate would be 1,000. So I am going to do 1,000 grams over 1 kilogram. And again, it doesn't matter if I put the 1 kilogram on top in my numerator or if I put it in my denominator, as long as I'm lining up my units, okay? So it doesn't matter which way it's written. I can do it either this way or I can do it this way. It does not matter which way. We are looking to find 6 kilograms. So I would put 6 kilograms next to my kilograms. You don't have to do it both ways. I'm just showing you how it works both ways. To get from 1 to 6, I multiply by 6, which means that I'm going to do the same thing to the 1,000 to find the number of grams. So it would give me 6,000 grams for my answer. So again, doesn't matter which one's in your numerator, which one's in your denominator, as long as in your equal fraction, your units are lining up. Okay, so you have some practice problems in PlayPosit. Go ahead and get started on that.